When winter winds howl or the summer sun sends temperatures soaring, it's a pretty good feeling to be comfortable inside a well-insulated home. And good insulation means more than comfort. It means big cost savings in these days of high energy prices. Now, for a homeowner, insulation is an investment that pays handsome dividends in comfort and economy. But like so many other products, all insulation is not created equal. Among the many insulation materials on today's market, there's one product that stands out from the crowd, and that is cellulose. By any standard you choose, inch for inch or dollar for dollar, cellulose is clearly the best loose-fill insulation you can install, and it offers the added advantage of recycling an important resource. You see, cellulose is the insulation material that makes sense and saves dollars. But not all cellulose insulation offers the safety and effectiveness a buyer has every right to expect. The product must be made properly and strict quality control enforced. So, how can a buyer or installer tell if material measures up to accepted standards? In the case of cellulose insulation, it's easy, because the industry has accepted its responsibility to buyers and installers by establishing a program to monitor and enforce compliance with all federal government standards that apply to the product. The Cellulose Industry Standards Enforcement, or CISEP, is a voluntary industry-wide program that means consumers can buy insulation carrying the CISEP quality seal with the confidence the material in the bag meets every standard of safety and effectiveness in the industry. Ron Baumgartner, CISEP's technical consultant, has over 30 years of thermal engineering experience. He has authored dozens of articles and reports on building thermal insulation. He's taught college-level courses and conducted seminars. He's currently secretary of the American Society for Testing and Materials Committee on Thermal Insulation, and he is chairman of the American Society of Heating, Refrigeration, and Air Conditioning Engineers Technical Committee on the Thermal Envelope of Buildings. Here's Ron to tell you more about CISEP and how it works to ensure that the cellulose insulation you install is the safest and most effective material money can buy.
So far, we've talked a great deal about tests, but what exactly do these tests prove, and who decided which tests to use? Well, it's important to realize that CISEP didn't arbitrarily pick some testing standards and then go into business. The program is based on enforcing compliance with the General Services Administration specification, HHI 515D, Consumer Product Safety Commission Safety Standard 16 CFR Part 1209, and the Federal Trade Commission Rule 16 CFR Part 460. Each test the manufacturer and the independent laboratory perform is required under one or more of the federal specifications, and each has a specific purpose. It confirms that a particular physical property is present or absent, and provides a basis for predicting the behavior of the product under a range of conditions. Now, one key test is, how well does the material insulate? How effective is it in resisting the movement of heat across the insulation barrier? And this value is established by measuring the insulation's resistance to the flow of heat from a warm side to a cold side of a test device. This test device is called a heat flow meter. The methods for using it are covered by ASTM Standard C518. Here's what one looks like.
Tell me when you want to put the tray in.
Anytime.
Okay, zoom in on the...
Well, nothing's happening at this point, though.
Usually I hit the lights off here, I don't know. I want the lights off.
Okay, now what we want to do is we want to cut the...
Might have been too long. Been in there about 4.5 minutes.
Yeah. That look okay, Mel?
We overheated the sample, that's why it's...
Now, the results of this thermal conductivity test are translated into the familiar R value, which permits direct comparisons between insulation products. R values are also used to describe the total resistance of a cross-section of a building envelope. The inside and outside finish materials, air spaces, and air films are included in this evaluation. Sometimes it is called the total R value. The higher the R value, the greater the resistance, and the more difficult it is for heat to flow from one surface to another. Cellulose insulation normally has an R value range of 3.4 to 3.7 per inch. Now, the next test is related to the previous one. It's called the settled density test. It tells us how much insulation is needed to end up with an honest-to-goodness R value. As the name implies, the purpose of this test is to determine how much the insulation will settle after it has been installed. Will a customer really have the R value represented for a given thickness?
Can you put that in there without standing more on the side?
Stay right there for a minute.
Good.
Okay, if you can move your head.
This one?
Yeah, just so it's not in the shadow.
You're looking right at it.
I mean, that looks like a, I mean, look at the
Maybe
monitor,
we'd have a
it looks-
better chance passing that test all the time if you did it that way, Bill.
Yes, sir, just from what we see on the monitor, it looks like you know what you're doing over there.
Done it a few times
Yeah.
a day.
The magic of all of them. Okay, keep trying to weigh it.
Okay, I'm keeping.
Yeah, I'll go into the close-up now rather than saying weight.
Okay.
Try it again. So where's the scale?
There's the scale.
Okay.
Here, that's good.
Now, I can't overemphasize the importance of knowing subtle densities. The test for thermal conductivity is performed at a fixed density. The typical R value for cellulose insulation material in relation to density is predictable. It can be plotted on a graph, and it looks like this. As you can see, it isn't a linear function. A low density is no more efficient than a high density. There is an optimal point right here. It's in the range of 2.0 to 2.8 pounds per cubic foot. The loose fill cellulose you buy should perform somewhere in this optimum range. Sidewall or closed cavity conditions change the rules on subtle density a bit because the insulation is blown into a restricted cavity under pressure. This is the preferred way to install loose fill insulation in an existing cavity. The blowing pressure compacts the cellulose to a density in excess of its normal settled value. And a very interesting thing happens. Cellulose insulation has a natural elasticity or springiness. You push, it pushes back, exerting force in every direction. It cannot settle if it's properly installed. Hard to believe? How about a demonstration? This demonstration panel is made to simulate a wall cavity. The insulation is blown into this space here. You see the insulation begin to rise right up through this cavity. This technique will be called the two-hole blow. The first hole is blown at the bottom, the insulation rising up to the top. We have to relieve the air pressure slightly. Now it would appear that the insulation has reached almost to the top of the stud run. The hose is inserted into the second hole. The application begins again, and you'll see the insulation begins to push downward and upward, completely filling the wall cavity. We'll pivot this wall around and we'll take a look at the backside of the insulation panel so you can see for yourself just how that insulation looks once it's been blown in. Now, had this product not been properly installed, obviously it would have fallen right out. As you can see, to get it out, you have to pick it out. That's the kind of a job that cellulose does when it's installed in the sidewall. This panel is made to simulate a wall cavity. The space between the vertical uprights is similar in dimension to most wood frame construction. And that's where the insulation goes. Of course, the carpenter, plumber, and electrician may have put a few things in ahead of you. Now, therein is one of the virtues of the cellulose fiber. It goes where air goes. Every little nook and crack is filled. Here's an example of how cellulose fiber insulation fills a wall cavity. There are still 6 more tests this product must pass before it's delivered to you. Three of them are relatively simple quality checks. The remainder are more complicated. Now let's dispense with the 3 simple tests first, and then spend our time with the more involved procedures. The first of these is for starch content. Why? Because starch has food value, and it could provide dinner for an unwelcome array of small creatures. And the next test is for odor. The reason for this evaluation procedure is obvious. No one wants to buy insulation that will produce an unpleasant odor in their building. Moisture absorption is next on the list. All cellulose materials, wood, paper, cloth, and wood laminates, have a natural moisture balance in relation to the environment. Manufacturing processes alter this balance with heat. How does insulation get wet? Well, that question by itself is a topic for a day-long discussion. Let's just say building leaks, defective water pipes, high humidity, uncontrolled vapor movement. Any or all can be the cause. We are concerned with the chemical reactions between the insulation and the metal building parts. Now, a corrosion test is used to determine if such reactions are likely to occur. It is conducted in two phases. Phase 1 is the twice-a-shift minimum sampling to verify the pH index of the finished product. A pH test establishes the degree of acidity or alkalinity. A product that is not close to neutral can cause corrosion. Now, the second phase of this test is conducted at least every 6 months by Underwriters Laboratories as a part of the ongoing random market sampling testing program. Metal test coupons are placed in contact with insulation samples in an accelerated corrosion environment for a 2-week period. The coupons are then examined for evidence of corrosion. The remaining test procedures are for fire safety. They identify the degree of fire resistance the insulation has when exposed to ignition sources. It might be well to mention that words like fireproof or fire safe are misleading, because there is no such thing as a standard fire to test against. Our primary concern is in rating these materials through established fire tests. These tests cover a variety of conditions, but in SciSep we test our fire resistance in the following predictable situations. Attic fires. They can be caused by single hotspots, such things as a covered recessed light, defective overheating wiring, defective chimney flues, and even careless smokers working in attics. The smoldering combustion test is tough. A high-temperature heat source, about 1400 degrees Fahrenheit, is inserted into the insulation and it remains there, glowing, for about 3 or 4 minutes. Combustion or smoldering afterwards means failure. In SciSep-approved plants, this test is performed every 2 hours. The next procedure was developed to test the response of floor covering in a fire. In this condition, intense radiant heat warms the materials to the ignition point. The burning rate cannot exceed a preset limit or the material fails. The idea is to simulate the effect of a fire where the roof burns first, exposing the attic below to radiant heat. The SciSep plants also conduct this test every 2 hours. Well, it appears now that we've tested for everything except your patience. We hope you found the story of SciSep's program worth your investment in time. Now let me add one more thought about this insulation material called cellulose fiber. Cellulose fiber is one of the most useful and versatile materials mankind uses. In addition to continuous testing during production, SciSep participants agreed to maintain a minimum of $500,000 product liability insurance as further proof of their commitment to quality product. Well, it appears now we've tested for everything except your patience. We hope that you found the story of SciSep's programs worth your investment in time. Now let me add one more thought about this insulation material called cellulose fiber. Cellulose fiber is one of the most versatile materials that mankind uses. We wear it, we walk on it, live in it, under it, over it. We eat it, we feed it to animals, heat our homes, clean up oil spills and make furniture of it. We write on it, read it, carry goods in it, make signs and hundreds of other useful products. Why not insulation? Thanks for watching, and remember the real meaning behind this logo. Buy with confidence. Every cellulose manufacturer under the SICEP program must have a laboratory fully equipped to perform all of the tests required by SICEP. All of the personnel must also be fully trained to perform all of the testing.
This is the smoldering combustion test.
We're gonna zero in. Okay. Now I'm gonna put the cigarette in.
Yeah. You want to make him give you something more interesting than tobacco.
I'm talking through Bart when he called her back. I was on the other phone, so we were trying to get him to bring $1,000 in order to get some more material and make some flour, but they can't do that. And so he said, well, just tell Bob to forget it. I'll get it someplace else. So we left it that way. Yeah. Yeah. Well,
That's good. Well, anybody that knows what neutral is.
Johnny been in at all since he's been back?
This is the extraction portion of the pH test.
No, this is starch.
Starch.
No, this is pH.
This is
pH.
still pH?
Mhm.
Okay.
And this in the regular sequence.
Yeah.
This is another version of the pH test.
Closer to 7 too. Very close to 7.
7 is, right at neutral. That's neutral.
Neutral, then neutral.
Yeah, well, it's not on the acid side, not on the alkaline side.
You can cut it.
Like so.
Got it.
Okay.
Alright.
Do I need to zoom in on?
No, I think
No, it's gonna be on such a short time.
There's nothing you can see.
why don't we just zoom in on that beaker?
That's it.
If there's nothing else, it shows that nothing is happening, okay, we'll cut it
Good.
now.
Probably
Good.
making it.
Yeah.
This is the preparation for the corrosion test.
Okay. Want me to cover them, or you just, that's enough?
No, I think go ahead and cover it now.
Okay. I'll just cover the one. We'll
Yeah,
see.
that's good.
Oh, the other 3 are in the picture.
Yeah, the other 3 are in the picture.
I didn't realize. Okay.
Other two,
Two. Yeah, just covering that now.
Those are probably
Good contact.
Okay, that'll to Mike Wallace for
it. That's moving.